Hello. Let me introduce you to the matrix factorization problem. Suppose you have a movie rating matrix. So that's a classic problem with the matrix factorization. You have some users and you have some movies, and all the users give some rating to each movie. And here you see Harry Potter. For this user, he gave him rating 3, and this user gave Harry Potter a rating of 3, and so on. But in real life situation, this matrix doesn't look like this, and it looks like this. So maybe this user has watched only 2 movies, this has watched the other 2 movies, and so on. And the problem is now, can we predict the rating of this movie for this user? Or in other words, can we recommend this movie to this user? Well, there will be a lot of movies, hundreds and thousands of users, so there will be a lot of movies that user hasn't watched. So we might want to recommend him those movies by guessing if he would like it, and to know if the user likes the movie, we have this rating things. So the whole question is, can we guess the values of the rating for a movie for any user? And here you can see, for this movie we want to guess if the user will like it or not. If this value happens to be 1, we won't recommend it to this user. If this value happens to be 5, then we would surely recommend it to this user. So it's really our prediction. So the core idea of how we can predict these values is very simple, and now I'll tell you that. So we have this 3 by 3 matrix, right? I want to split this matrix into 2 matrices, right? That is what I want to do. I will split this matrices into 2 matrices, and if I combine those matrices again, I should get something like this. And that is how factorization is, right? You remember from your school that if I have, for example, 24, how can I split it into 2? Well, I can, for example, say 4 times, or let's say 2 times 13, right? So this is the factorization of 26, right? And that is what I'm going to do. This is my, for example, 26, and I want to know the 2 and 13. And if I'm lucky enough to get those matrices good enough, right, I will be able to predict the missing values, right? And this is really the core idea, right? So we have to factorize this matrix into 2 parts to predict the missing values. Let me give you a little more concrete example. So suppose I have these 2 matrices, the decomposition of the original matrix. Then what can happen? If I take the dot product of this row and this column, I get the rating for this movie. If I take the dot product for this row and this column, I know the rating for this movie, and so on, right? So even if there are some missing places, if I have the factorization of this matrix, then I will be able to predict those values. But the question is, how can I get a good value for this factorization, right? I don't know what these factorization are. So the answer to that is we will have to find it out by trial and error. And although because of these missing values we won't be able to find it exactly, what we will do is we will find it approximately. That is what we do in machine learning, right? So we will approximately find the decomposition of this matrix. So this will give us an approximate resultant matrix. But the good thing is, because it's approximate, now we can approximate these values as well, right? So that is what